Congruent figures, if it lets me go, are geometric figures that have the same size and shape. This was a term on your scrapbook project. So geometric figures that have the same size and shape. I believe Mackenzie needed that. Is that what you're staring at? The next one I will explain to you after you write it down. It'll make sense. It's called rigid motion. Rigid motion is a transformation that preserves length and angle measure. So rigid motion is a transformation that I just can't talk anymore. You can read. So sorry. Preserves length and angle measure. So I'll show you with an example. These are passes to this class. It's very interesting because they're from the same person. But anyways, these are congruent. Yes, we agree? Yes. So all rigid motion says is that they're congruent in every way. Even if I take this one over here, even if I turn it, even if I flip it, things like that. They're still congruent. You're going to be given two triangles, and you're going to decide if that's what's happened. If one has been slid over, flipped, things like that, and to see if they're still congruent. Okay? So, before that, in the last section in 5.2, we decided in order for two shapes to be congruent, the angles needed to be congruent. What else needed to be congruent? The sides needed to be congruent. But in this section, it's the same thing, except for you don't need as much information anymore. How many pieces of information are in one triangle if all the angles are marked congruent and all the sides are marked congruent? How many pieces of information is that? That's 6. 3 angles, 3 sides. You're going to learn now that you only need 3 pieces of information. And that's where the letters SAS come in. Because what does S stand for? A side, and then an angle, and then a side. So we'll talk about that. So, in order for two triangles to be congruent, all the sides and all the angles must be congruent. That's what I just showed you. Let's fill in the blank. In order for two triangles to be congruent, all sides and angles must be congruent. Did you already fill it in? Oh, my bad. But this is what you're going to write in and then highlight. This is the whole point of the next 3 lessons. You don't actually need to know every side and every angle to know two triangles are congruent. That's why these theorems are here. So you don't need to know every side and angle to know that the triangles are congruent. You're going to learn specific theorems that will prove it. Okay. That would help you, but it's too difficult. So the first theorem, you see theorem 5.5. Can you take a stab at what you think it's called? What the whole lesson's called?
Proving triangle.
Side angle side. Proving triangle congruence by side angle side. So side angle side, and then you write SAS next to it. That is the shortened version. But again, you would never out loud say SAS. You would just say side angle side. Because they're all one syllable, it doesn't take that much effort. So it says if two sides and the included angle of one triangle so if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. So, here is what this means. What is the word that's bolded twice? Included. So I would write off to the side what this means. When it says included, It means between. So if two sides and the angle between them are marked congruent, then the two triangles will be congruent. So here's what that looks like. So if you have two sides marked congruent, let's say we had these two marked congruent to these two, and an included angle marked congruent. So included means between. So if you look, you got this side and this side. The angle between them is this bottom left. So if this angle is marked congruent to this one, these three pieces of information is enough to prove that the two triangles are congruent. We call this side angle side. Side angle side. We'll do the example that's on your paper. You'll see these two triangles. If you look, you have a large letter S, right? And then there's a blank. You're going to fill in that blank with PQ is congruent to WX. So PQ is congruent to WX. Right there. And then I would put the little dashes on the triangle. So PQ marked congruent to WX. So we have a side marked congruent, then we would need an angle. So they picked angle Q and angle X. So there's your angle congruent. From here we should be able to guess the other side, because the angle has to be between the two sides that are marked congruent. So currently, this is a side. Here's our angle. What would the second side have to be in order for Q to be in the middle? The other one, which we would call? Just name it. QS. So QS would have to be congruent to XY. QS, XY. So because of this, then we would know PQS, triangle PQS, is congruent to triangle WXY. This is another blank. So then PQS is congruent to triangle WXY. Do you have bad eyesight? Isn't that what bad eyesight would imply? You just can't turn your neck? You wear glasses? There's no shame in glasses. There's no I like when you wear your glasses, right? Don't you wear glasses? They look nice. They're what? I hate when that happens. So, it says remember the blank property, right? You're going to write, remember the reflexive property, and then I'll explain why. Remember the reflexive property. This is a property that's redundant. If you look at the example it has on the screen, it says triangle ABC is congruent to triangle ABC. I wouldn't turn yet. I would go back. I wouldn't turn the page up. Triangle ABC is congruent to triangle ABC. It's very redundant, but here is where it matters. In this picture, how many sides are marked congruent from my first triangle to my second triangle? Two sets of sides, right? But the third side is still congruent, and here is why. Y'all see DB? They share that wall, correct? Look at my wall. I share this wall with Ms. Dix, right? If it's 30 feet on my side, what's the length on her side? 30 feet, because it's the same wall, right? So this is where you would say a side is congruent to itself. So what you're going to write as like a note, when you have an overlapping side, so overlapping sides are congruent to themselves. Overlapping sides are congruent to themselves. I don't know if that's grammatically correct, but it is what it is. So what this means is they both share DB. So it's not marked congruent, but you could mark it congruent to itself if that helps you visually. because in some problems you're going to have to. So we would say DB is congruent to DB. This would be a statement that you would make about this side being congruent to itself. And we'll see it actually in our next picture. Now you can flip. DB is congruent to DB with line load. I could switch your tables. I don't want him in the back. This guy. Look, he's paid attention more than he ever has. No, what? Here we go. Here we go. So we're going to prove that triangle ABC is congruent to triangle CDA. So ABC is the top, CDA is the bottom. We've only learned one way to prove they're congruent, and it's called side angle side. So we're going to use the side angle side theorem to prove they are congruent. So we're going to write it off to the side like there it was on the first page. So SAS. We're going to find a side congruent to a side, an angle congruent to an angle, and then a side congruent to a side. The first one is marked, and it's given actually in the directions. But what side is marked congruent on the first triangle? BC. So you're going to write BC. BC. What is BC congruent to on the second triangle? So it does matter the order you say it in. It'd be DA. It also says in the directions right here. But here's why. B is the second letter, so what does it correspond with? D, and then, yeah. So BC and DA. That's why. It has to be in that order. We're going to skip the angle for now. We'll go back to it. The last one is a side. What side is congruent on both shapes? AC. Remember the reflexive property? They both share this wall. If I took apart the two sides, or the two triangles, AC would still be congruent to AC. So AC is congruent to AC. A side is congruent to itself. So they both share that wall. The last one would be the angle. Where does the angle have to be in comparison to my two sides? In between, right? So we're just going to go through. Is this between my two sides, the green and the orange? No. Is this between the green and the orange? No. Is this between the green and the orange? Yes. So we need to name this angle. I'm going to tell you right now you cannot say angle C. Can anybody tell me why we cannot name it just angle C? Yeah, there's another angle C. There's this one. There's even the outer angle. So you can't say just C. What you can say, however, are three letters. When you name an angle, you name it like you're drawing it. So everyone see how I drew like this? So we can either start with B. If I started with the letter B, what letter would go next? C, and then A. So angle BCA. That was a weird noise. Inside of the second triangle, you want to do the same thing. You want the angle between your two sides. So that would be this angle down here. It's between the orange side and the green side again. If I said BCA in the first shape, or the first triangle, what would I have to say in the second?
Angle DAC.
DAC. DAC. So we didn't just make this up. We didn't just decide, well, they look congruent. If you remember, what do these little triangles mean?
They're parallel.
They're parallel, so I just drew the BC and the AD, okay? They have a line going through, right? This line right here. What do we call one line that cuts through two lines?
Transversal.
The transversal. All right, and then we marked these two angles congruent. What relationship do these two angles have?
Alternate interior.
Alternate interior. What do we know about alternate interior angles? They're congruent. So did I poof it out of the sky that these two angles are congruent? No. Okay. So this would be enough to prove that the two triangles are congruent. The side, the angle, and the side. So you're actually going to box all of it in. All of it is the answer. this next part, we slow it down. That was probably as hard as they get. Except for this is where my 3rd hour setup camp. It's not supposed to be a hard question. Name the included angle between the pair of sides given. So basically, we're given the sides. We need to find the angle in between them. So we're going to read them. We got JK and KL. It does help if you draw on your picture. JK and KL. It wants us to name the angle that would be in between. So what is the vertex, we'll just say the vertex, of the angle that would be in between these two segments? K. But I can't say just angle K, because again, there's this angle, and this angle. So we would say angle JKL. Or what's the second option? LKJ. Good. That's all it's asking. How do we feel? Okay. Good. Let's move on to the next one. LP and LK. So again, it wants to name the angle in between, which would be this one. Sure. Angle PLK. Or we could reverse it. Angle KLP. And then the last, what does it say? KL and JL. Yep. Angle JLK, or we could say KLJ. That's it. We good? Because apparently they don't remember how to name angles. It's fine. It's not. But it's fine. So, in this section, we're going to decide if side angle side is being used. Yours, the 4 pictures go across the top. Mine had more room, so I did this. We're going to start with it's my tops all the way to your left. Here's how you do this. You're going to compare one triangle to the other. We're going to see if we have side angle side to decide if these two triangles are congruent. So we just go through each letter, side, angle, side. Do we have a side on my top triangle marked congruent to my second triangle? Yes. So I usually write an S for a side that's congruent to a side. I only write it once in the one triangle. Do we have an angle? We do have an angle marked congruent to an angle. Do we have another side?
Yes.
We do, and it is the side that they share. So I need you to pause and think about this. We're trying to prove side angle side. Where did the angle have to be? In the middle between my two sides. So you need to look and see. Here's one side. Here's the other. Is my angle included between my two sides?
No.
It is a no. In order for it to be a yes, the angle would have had to been over here. This is not a theorem at all. Remember how I said there are 5 theorems? Side-side angle is not a theorem because you don't have to say it out loud, but just think about what it spells backwards. Side-side angle. Angle side-side. Is not a theorem. It will never be a theorem. It will literally be a question on a quiz if it is a theorem. And some people still mark it, and it's not. Okay? So I want you to remember. It's very easy to remember. It's a bad word. Whatever. Would that be a theorem in a geometry book for teenagers? No, it would not. So keep that in mind. Starting out there. Moving on. This next one, again, we're going to compare one triangle to the other. Do we have... Well, let's just talk about what we do have. What do these little marks mean on the left? A congruent. So we have a congruent angle. We have another one on the right side. Do we have any sides?
No.
Yes, we do. The one they share.
Oh, yeah.
The one in the middle. Does this prove side angle side?
No.
No. I will tell you, however, angle side angle is a theorem. You just haven't learned it yet. So in this particular section, we're just deciding if it's side angle side. It's not, but you'll eventually learn This is angle, side angle. You'll get it. This next one. We're going to compare these triangles. We have a side congruent to a side congruent to a side. It appears we don't have an angle. We do. We have vertical angles. Good. What do we know about vertical angles? They're congruent. So it's not marked, but you can mark it yourself. So is this side angle side? Yes, it is. So again, we know vertical angles are congruent. It's just understood. So you are allowed to write that in. The last one, we're going to compare the top triangle to the bottom. We have a side congruent to a side. Do we have angles that are congruent? Yes. Does it matter that their lines are uneven? No. So the reason they're uneven is so you don't think we're talking about one big angle. We're talking about two separate angles. So that is an angle marked congruent to an angle. And then do we have another side? Yes, the one they share. So is this side angle side? Yes. Good. All right. We got these two, and then we're done. I would put a star next to this. This is about half the quiz. On the quiz, it'll say state what information is required in order to know that the triangles are congruent for the reason given. We're trying to prove these two triangles are congruent by side angle side. We're missing something. So we need to list what we're missing in the triangles to have side angle side. So we need to find out what we do have to know what we don't have. So we'll start there. Do we have sides that are marked congruent? Yes. Do we have angles that are congruent? Yes. We got 90-degree angles, which are congruent, you know. So we have side angle. We're missing a side, right? So the main thing is we need to find a side, and the angle has to be between the two congruent sides. So what would the second side have to be on my first triangle? CA. So you would say CA. It does matter the order of the letters for the second triangle. If I said CA in the first triangle, it would have to be congruent to LJ. And that's your answer. You could have reversed the letters. I did hear someone say AC. But if I said AC, I would have to say JL. That's all. So both are correct. Both are fine. Okay. Second one. Do we have a side congruent on both triangles?
No.
Yes, we do. And it's the side they share. It's okay. That's why we do it over and over again. So we got the side they share. Do we have an angle that's congruent? Yes, we have the right angles. So again, we're missing a side. So what side in my first triangle would need to be congruent? WV. But yes, you were just, I was talking about this one. You're not wrong. So if I said WV in my first triangle, what would I have to name my second side? KX. Good. Before you put it away, we're going to just recap two things. All right, so just the two things that we talked about, what you can mark on a picture. You can't ever say, oh, well, this side looks like it's congruent to that side. That's not a thing. We said that you could on two different things. What did we mark congruent on this problem? This side. So when you have an overlapping side, I would write this in, just so you have it in one place. You can mark overlapping sides as congruent. The second thing we marked was on the last slide. Does anyone remember something that we marked congruent? It was an angle. Close. Vertical angles. Good. So you can mark vertical angles congruent because it's understood that they are congruent. All right, so this is where we stop.